A lot of videos online are claiming that a US destroyer without Tomahawks is forced to abandon the fight and run back to Diego Garcia. They tell a dramatic story about a massive gap forming in the fleet defensive screen while a warship retreats across the open ocean. That narrative is simply false because the military planners already solved the at-sea reload problem long before the missiles flew. Critics ignore basic naval doctrine since CSG rotation ensures that when one Arleigh Burke taps out, another seamlessly plugs the gap. But revealing the truth about fleet logistics exposes a much darker and multi-billion-dollar crisis that media channels refuse to see. The United States Navy did not just run out of vertical launch cells because they actually collided with a terrifying mathematical wall. When you are continuously firing $3 million Tomahawks at $20,000 targets, the primary issue is not the firepower. It is a pure nightmare of sustainment that will dictate the winner of the next global conflict, regardless of how advanced the radars are. In high-intensity conflicts, the ultimate deciding factor is not just the advanced radar, but the sheer magazine depth of the strike group. This concept dictates exactly how long a fleet can sustain continuous fire against a determined enemy without running out of interceptors. Many armchair generals confidently claim that a warship leaving the combat zone creates a fatal vulnerability for the remaining defenders. They fail to understand the absolute scale of a carrier task force and the overlapping layers of mutual defense that protect every vessel. We are witnessing the most severe test of American maritime logistical chains since the brutal island-hopping campaigns of the Pacific War. You are about to discover the terrifying reality of modern naval warfare that the Pentagon desperately wants to keep out of the headlines. Let us dive deep into the real numbers and the heavy machinery that actually determine whether a superpower can hold its ground in combat. The media continues to paint a picture of stranded warships waiting for weeks at a concrete pier while the enemy freely roams the waters. This theatrical description works perfectly for gathering views, but it misses the actual structural weakness of the surface fleet entirely. Prepare to unlearn what you thought you knew about naval dominance, as we strip away the myths and expose the raw arithmetic of this battle. To understand the true mechanics of naval combat, you must abandon the idea of a lone ship fighting entirely by itself in the open ocean. An Arleigh Burke-class destroyer is never an isolated fortress because it operates as a deeply integrated node within a massive network. The carrier strike group is a synchronized ballet of lethal assets that continuously share targeting data across encrypted data links. When a frontline warship depletes its magazines after launching dozens of interceptors, the fleet commander simply shifts the formation. Another fully armed destroyer smoothly slides into the vacant sector while the exhausted vessel maneuvers behind the defensive screen. This seamless transition guarantees that the overarching Aegis combat system never suffers a blind spot during intense combat operations. Opposing forces, hoping to exploit a sudden gap in the perimeter, will find themselves instantly targeted by fresh weapons from another ship. The sheer density of vertical launch cells distributed across multiple cruisers and destroyers creates a practically impenetrable shield. A single strike group entering the theater can easily bring more than 500 precision missiles into the immediate battle space. If you imagine a fleet as a collection of separate boats, you are missing the absolute brilliance of modern integrated warfare architecture. War planners have spent decades perfecting this rotational strategy to ensure continuous power projection across hostile maritime domains. The theoretical vulnerability of an empty magazine only matters if the enemy survives long enough to actually breach the outer defenses. However, this impressive tactical choreography is still fundamentally tied to the physical limits of moving heavy ammunition across the sea. Rotating ships solves the immediate problem of localized defensive gaps, but it does not address the core issue of reloading those weapons. For years, the logistical chain demanded that an exhausted warship journey hundreds of miles to find a stable crane on a concrete pier. The ocean waves transform a suspended missile canister into a deadly pendulum that can easily crush equipment and kill the working sailors. Engineers struggled to thread a violently swinging 3,000-pound explosive needle into a tightly constrained vertical steel sleeve. That insurmountable hurdle forced the commanders to accept the agonizing reality of pulling vital assets away from the front lines entirely. But technological stagnation is unacceptable in high-stakes competition, and naval engineers have finally cracked the at-sea reload puzzle. The implementation of TRAM has revolutionized maritime logistics. allowing destroyers to replenish VLS cells while underway. For decades, the unforgiving physics of the open ocean made it completely impossible to lower heavy explosives into a steel tube. Whenever a traditional crane lifted a massive cruise missile, the rolling sea instantly transformed the payload into a wild pendulum. That swinging momentum would inevitably slam the delicate munition against the narrow steel walls and threaten the entire vessel. But brilliant engineers at the Johns Hopkins Applied Physics Laboratory finally designed a mechanical solution to kill the pendulum. The brand new transferable reload at sea method utilizes rigid hydraulic arms to aggressively clamp the canister holding the weapon. Instead of suspending the precious cargo from a freely swaying cable, this innovative rail system locks directly onto the ship frame. When the warship aggressively pitches and rolls in rough waters, the mechanical arm and the steel canister move together in unison. This synchronized movement entirely eliminates the dangerous relative motion that previously made deep water resupply a suicide mission. In late 2024, the Navy successfully demonstrated this groundbreaking capability aboard the cruiser USS Chosen off California. Sailors smoothly transferred an instrumented test canister from a supply ship and mechanically slid it right into the vertical launch cell. This flawless execution in moderate swells definitively proved that frontline warships no longer need to flee the designated combat zone. Future destroyers will seamlessly pull alongside a massive logistics vessel and rearm their offensive magazines right in the battle space. By neutralizing unpredictable forces of nature, the American fleet fundamentally rewrote the operational playbook for naval dominance. However, solving the physical handling of explosive munitions exposed a far more terrifying limitation in the military supply chain. Even if the hydraulic arms of the tram system function flawlessly during a storm, the logistics vessels must actually have cargo. We are shifting from a war of attrition to a war of sustainment, where the factory floor is just as critical as the front line. The mathematical reality of firing 850 cruise missiles in a 5-week window is absolutely terrifying to see. American commanders are launching precision weapons that cost almost $3 million to obliterate extremely cheap targets. The defense contractor RTX currently manufactures a maximum of 100 Tomahawk missiles during an entire year of operations. This means the naval forces aggressively burn through roughly 10 years of industrial production in just 35 short days. You cannot magically accelerate a manufacturing line with a simple software update because forging specialized metal requires time. Each advanced munition relies on thousands of intricate components sourced from hundreds of different independent subcontractors. The standard lead time to deliver a single finished cruise missile to the surface fleet stretches beyond 24 long months. The brutal truth is that our warships are launching high-end munitions significantly faster than any factory can ever build them. A mechanized rail system on the ocean perfectly solves the loading equation, but it cannot miraculously print complex rocket motors. If the massive supply ships arriving from the homeland do not carry fresh weapons, the frontline destroyers remain entirely useless. The supply chain vulnerability extends far beyond offensive cruise missiles and heavily impacts the defensive interceptors too. Advanced surface-to-air weapons like the SM-2 and SM-6 are absolutely critical for shielding the carrier strike group from harm. These highly sophisticated supersonic interceptors require incredibly rare materials and specialized manufacturing facilities. Whenever a destroyer fires a salvo to defeat an incoming drone swarm, it depletes a stockpile that took several years to create. The defense industry cannot simply flip a switch and instantly mass-produce these highly classified thermal tracking guidance systems. This extremely fragile procurement pipeline places the entire naval combat force in a deeply compromised strategic position right now. If the fleet exhausts its defensive magazines against cheap asymmetric threats, it will stand defenseless against a peer adversary. Military planners are slowly realizing that the ultimate limit on American power projection is the industrial capacity of the nation. We have optimized our factories for maximum corporate profitability instead of planning for the brutal surge of a prolonged conflict. The uncomfortable truth is that a fully loaded warship is only as deadly as the vulnerable logistical network standing right behind it. A potential war in the Pacific would demand tens of thousands of reliable interceptors to counter the overwhelming enemy missile barrages. Current production rates mean that replacing the munitions spent in just 1 week of heavy fighting will require multiple years of labor. This mathematical disparity between consumption and production forms the greatest strategic vulnerability for the United States Navy today. Every single Tomahawk and Interceptor launched effectively burns through a massive pile of taxpayer money that cannot be replaced quickly. Foreign adversaries are carefully watching this exact logistical bottleneck and adjusting their long-term combat strategies accordingly. They recognize that forcing the American fleet to expend its expensive high-tech arsenal early will leave it critically exposed later on. The fundamental architecture of our maritime strike capability is built on the false assumption that any future war will be extremely short. When conflicts stretch into endless months, the advantage shifts drastically toward the nation with the most resilient industrial base. We must acknowledge that our current acquisition processes are far too sluggish to support the terrifying realities of modern high-end war. Without a massive revitalization of the domestic manufacturing sector, the greatest warships on Earth will simply become floating museums. This massive logistical bottleneck is exactly why naval architects are arguing for the return of arsenal ships to the modern fleet. The traditional concept of building multi-billion-dollar warships that carry less than 100 missiles is no longer viable. We must completely rethink our fundamental maritime architecture if we want to survive a prolonged engagement against a peer state. An arsenal ship is essentially a heavily armored barge that functions entirely as a minimally manned missile mule for the military. Instead of outfitting these vessels with extremely expensive radar arrays and massive crew complements, we strip them down entirely. These floating platforms would carry hundreds or even thousands of vertical launch cells packed with lethal offensive capabilities. The tactical brilliance of this design relies entirely on the secure encrypted data links connecting the entire battle formation. A forward-deployed Arleigh Burke destroyer would utilize its advanced Aegis radar to paint targets hundreds of miles over the horizon. The destroyer then seamlessly passes that critical targeting telemetry back to the heavily armed arsenal ship waiting safely behind. This networked approach effectively separates the expensive sensory equipment from the massive volatile magazines holding the weapons. By constructing cheap commercial-grade hulls to carry our excess munitions, we drastically increase the overall magazine depth available. A single cargo vessel converted into a dedicated strike platform could instantly double the firepower of an entire carrier strike group. This asymmetrical solution radically alters the terrifying math of modern warfare by flooding the immediate theater with raw capacity. Opposing commanders would face an impossible dilemma when confronted with overwhelming waves of incoming strikes from these ghost ships. The United States must embrace this brutal industrial pragmatism rather than continuously relying on exquisite and fragile technologies. If we fail to rapidly deploy these cost-effective missile trucks, our heavily armed adversaries will simply outlast our limited reserves. However, the ultimate asymmetric solution might not require massive floating magazines or expensive traditional cruise missiles at all. Military strategists are aggressively pushing for a complete paradigm shift towards swarms of low-cost and highly disposable combat drones. Instead of launching a single $3 million precision weapon, we could deploy thousands of cheap autonomous vehicles simultaneously. These networked aerial systems would completely overwhelm sophisticated enemy air defenses through sheer numbers and relentless saturation. Commercial manufacturing facilities could effortlessly produce these expendable drones by the thousands without facing complex bottlenecks. This radical approach flips the terrifying economic math of modern warfare directly back onto our deeply entrenched global adversaries. We can effectively force the opposing military to waste their most expensive defense interceptors on incredibly cheap plastic composites. Once their heavily fortified magazines are completely emptied out, the secondary wave of unmanned systems will effortlessly strike the base. The undeniable future of maritime combat lies in accepting the brutal reality that perfection is the ultimate enemy of sustainable volume. So here is the ultimate question for you to answer regarding the next major conflict happening across the contested Pacific theater today. Should the U.S. Navy invest billions into reviving massive arsenal ships that are packed with thousands of incredibly lethal cruise missiles? Or should they completely pivot their current strategy to rely on massive swarms of low-cost and highly disposable combat drone systems? Drop your tactical assessment in the comments below right now, and I will immediately pin the best strategic breakdown for everyone to see.